Okay, so welcome everybody. This is Showcase 11. They are flying. This is the first one we've actually done since the previous one publicly. So Showcase 11. There's a few things to discuss. We've had a busy few months. I think everyone's still come to terms with the new working from home realities and things. But we've maintained a decent amount of momentum with Crux, and a lot of good stuff has been happening. So this week we've got most of the team speaking, and an opportunity to ask questions later on. Although if you have some burning questions, feel free to interrupt the flow. We've got a couple of people on the call live, and obviously this will be going out to YouTube later. So 1.81 we released a small release earlier this week to mainly address an issue with the Kafka client and a connection problem we were having with Confluent Cloud specifically, although it may apply to other Kafka installations to do with polling. And I won't pretend I fully understand the implications of it, but anyway, we just increased the timeout, and seems to resolve the issue for one of our users, which we're happy to report. So that was 1.81, so it's a fairly minor release. But yeah, there'll probably be another one in the not too distant future, as we have quite a few changes lined up. So first exciting thing to talk about would be our work on SQL. So you may have heard before that we've been looking at integrating something called Apache Calcite with Crux. So Calcite gives a SQL query layer to sort of a generic backend. So you could actually implement Calcite against like a CSV file, and it will produce an interface that allows you to run SQL queries. And it's actually doing the hard work of figuring out how to traverse the file. You just define some very simple operators, but the more work you put into Calcite, the faster it gets, the more performant it gets. So in order to build a very simple integration, it's not actually too much work, and we've done the sort of initial work for that, or with an initial approach. We can describe how that works, but the more time we invest into Calcite, the faster the integration will be, and the more SQL features it will support sort of semi-natively. So John has actually been leading the work on that. So John, I don't know if you want to take over at this point and just discuss what you've been up to.
I'll give a brief tour, if everyone can hear me okay. I've been told my fan's a little bit noisy, so apologies for that.
Loud and clear.
Sorry?
You're loud and clear right now.
Okay, cool. I'll just share my screen as well. Can I do that? Is that possible?
Yeah, you go for it.
So share my entire window. Guess that's arguably a risky thing to do, but never mind. Okay, can everyone see each other? So can everyone see my Emacs? Yep. Say no if you can't hear my Emacs.
Yep.
Okay.
Oh wait, no, sorry, no, I can't see.
I can see your Chrome, but not your Emacs.
Really? Stop presenting. Present now. My entire screen. Okay. How about now?
Yes, Emacs. Yeah.
Happy days. Okay. So Calcite is a module within Crux. So that means that you can wire it in simply by specifying you want to add the Calcite module to the Crux topology. So this is standard Crux config. And here's how you add the Calcite module. And you need to hook it in as a standard dependency, as you would do in your deps.eden or project.clj file. But then once you load this in, then you can actually form a connection via Jdbc, and it looks a bit like this. So this is standard Java SQL code here to grab hold of a connection, and this would be the URL of your Crux node here. This would be the host name, and that's a standard port, although you can take a property to override that if you want. And then from here on in, you can issue standard Jdbc queries. We have a couple of those I'd just like to show. So we have a test file here. This is like the hello world Calcite file. And here you can see we're performing SQL queries. And then we're getting normal Clojure data structures back. We're using the Clojure Next Jdbc library by Sean Caulfield here. to grab hold of the data via SQL, and then to put it into Java maps, and then we test it. What we get back is what we expect. You might be wondering how this actually works. So what we are asking users to do to bridge the gap between the schemaless Crux and SQL, which very much expects a schema of columns and column types, is that you should insert a document like this for each table definition. And inside this document, we specify the table name. So here we have a we have a table called person, and then you specify the columns. So here we have a column. The name of that column is ID. Actually, I'll start with this one. The name of this column is name. The type of it is a string of varchar, and the attribute in Crux is name. So what will happen here is that when we issue a SQL query, it will match any document to this table that has these particular attributes. So any document that has the attributes ID in this case, but then name, homeworld, and this one, any document that matches all of those columns will basically be part of that table. It seems to be part of that table, and that's pretty much the basics of it. So here we've got various tests. I'll come a bit more onto our testing strategy to make sure that we are compliant. I just want to cover one more thing, in that you can also specify a query to back a table as well. So in this case, we're saying it's not just that every document that's a candidate to be part of this table must have these attributes that map to these columns. You can also represent a table by a query. So here we're going to pull back all documents that have the attribute planet equal to Earth as the value. So that gives you a little bit more flexibility if you want to be able to do joins and fairly complicated data log stuff, but then it's difficult to represent that as SQL. You've got the ability to drop down and specify a rule that determines what that table actually maps to in terms of data log rules. So that's the basics of SQL. We've been experimenting recently with this test suite called TPCH, and this is from the Transaction Processing Performance Council. And if you look at their website, tpc.org, and what this group does is that they've come up with these fairly complicated SQL queries here. So here's one example. This is 001. And there's quite a few of them. If I look at the Calcite have also ported this across, and this is used by lots of different databases that offer SQL. So it's used by Presto as well, for example. And this is the port of it that Calcite have done to test Calcite. So here you can see there's lots of them, these massive queries. And you can see that some of them don't actually work with Calcite. So there's one here which is disabled, planning succeeds, but it out of memories. It's such a huge, vast query, probably infinite planning. This one just goes away and plans forever. So these really do exhaust and sort of break the Calcite implementation. And the Calcite team are presumably working hard, or they've got some plan to try and get through as many of these tests as they can. So obviously, we're not going to be able to do all of them because Calcite can't do all of them, and we go through Calcite. But nevertheless, it's good for us to pick some that really test our SQL that we provide via Calcite, that we've hooked into Calcite in an adequate way. So we do boil down to data log the right way, and we've got the right data types in place. And it definitely showed a few things that we were doing wrong, and it's forced us to be a bit more compliant. So here we've just cherry picked a few that, see this one, for instance, Calcite. This one works with Calcite, but it hangs for us. So there's probably some more work to do there. But it's very exhaustive. And our plan for Calcite right now is to provide an offering where you can pretty much get most things done that you need, and you've got that back door where you can always map a arbitrary query to the table definition in Crux. So you can actually represent SQL tables very much as a view that map down to some complex arbitrary Crux query. So there isn't really so much of a need right now to really offer the full power that Calcite could offer. There's far more hooks and things that we can do. We can get closer to Calcite if we need to in the future. But what we've got now is very much a good MVP. And I think if you're in a situation where you have a project, you're using Crux, you're using Datalog, but then you have some business users and they just need to get the data out via SQL. Perhaps they want to put it into Tableau, or they want to ingest it into a spreadsheet, or they just want to do a SQL query, which is fair enough, because it's far more popular than Datalog. Then hopefully this will be a bridge, and it will be it'd be like a sort of useful tool that doesn't box you in to one particular way of querying data, which is Datalog. So I think I'll pause there. Have we got any questions that people would like to ask?
So I think it was great. I guess I already know the answer, but obviously we know Crux has a sort of lazy query capability. How does that map to Calcite?
That's a good question. So the queries that you get out of Crux are lazy. Calcite, if you do joins or if you do expressions like group by and max and min, then those are obviously going to pull all of the data set back. I need to test it actually to see what happens if you got a large data set, and to see whether it'd be lazy all the way through from next Jdbc to the way that you would consume it from a Jdbc result set or whatever, to make sure it's lazy all the way through to Crux, so it doesn't have to hijack everything in memory. That's a good bit of feedback. It's a good test. Yeah, we should do that.
But the TPCH benchmark, you already said that's like hundreds of thousands of documents, right, or something. It was quite a large.
Yeah. So if I just go back to my, you've got me in the TPHC. It's an impossible word to say, by the way. The amount of times I've misspelled TC or TH or TP. I'll just show one thing quickly. So inside this fixture here, we've got a TP TH transaction processing. That's the way to think about it. So here, the Presto guys, they've ported TP/CH across onto GitHub, so you can see the code. I've got all the code here, and from here, it's quite useful. So TP/CH table get tables gives you all the tables, and then I've got a query there which says, well, give me the schemas. If I just go into the REPL, I think I'll do it here easier. This is a Crux schema. A table schema for the TP/CH customer table, because that happens to be the first one. Here we can pretty easily just generate all of the schemas that we need for all of the TP/CH tables, which is quite cool. That's like the first thing I think is quite cool. But the next thing is TP/CH. It has these generators that you can use, which is really cool as well. So if I wanted to, I could say TP/CH table docs. Give me some docs, please. And I want to do it for TP/CH table. I want to do it for orders. But give me some. Actually, I'll do customers. Because why not? Customer. Give me some of those, please. And this it starts off with 150,000, but I've asked for 0.005 of those because I've had lots of times when I've had to crash my Emacs because I've done crazy stuff with it. But for instance, if I just do take 2 here, because I'm still a little bit afraid of crashing my Emacs, then here, this is generated data by TP/CH using their Java library. How cool is that? And the generators have smarts in them, so the customer will have some relationships with the orders and the line items that it creates. So, for instance, in the test that we've got here, when we do an arbitrary query like this is actually bringing stuff back because those generators are building in relationships. So it's very, very nice. There's lots of work that has gone into this, and we're able to make use of it. So thank you to the Transaction Processing Council.
That's great. Cool. Any other questions, Mariam? Alex says, what's driving this feature? A customer requirement or just trying to appeal to a wider audience? So I guess I'll take that. So it really is, well, we have had a few people say they want to connect like Metabase or Tableau to Crux. So in a sense, it's responding to that, but also we know that the mass appeal, the buzz, I guess, you can get from saying you support SQL is real. So we're looking to capitalize on that, I suppose. Although ultimately, we're still passionate about Datalog being in many ways better. Yeah, so it's just another optional component of Crux, and reinforces the idea that you don't have to use all these bits of Crux if you don't want to. It's just a module. So that's my answer. If there's anything else to add, John. Okay. Thanks, Alex. Okay, so I will jump back to my presentation, which shows the next thing to talk about is James, who has been working on changes to the index, and this is with the support of John and Håkan, and I've been listening in intently. Yeah, I guess these aren't even necessarily comprehensively the changes that you're looking at, James, but did you want to say a few words on this?
Yeah, absolutely. So over the last few weeks, really, well, last few internals of Crux in several different areas. So for those of you who keep an eye on the 1.8.0 release, that one was a lot more about the ingest and query speeds, and we spent quite a long time in that release, fixing a few issue code. Since then we've actually been looking a bit more at the disk space usage of Crux as well. So obviously with databases like Crux, we understand that because we're keeping the entire history of all of your data, it's naturally going to take up more disk space than a more conventional database, shall we say. But we'd like to both measure that and make sure that we're not using too much in terms of that storage. Particularly for people with sort of storage constraints. I mean, it's quite easy to sit here with the likes of Amazon and know, right? Yeah, you got so much storage available to you, and it's getting cheaper by the day. But we do recognise that there are people out there with those kind of constraints as well, and that we want to generally bring costs down. So to do this, we've been looking at a few things within Crux, particularly around particularly within Crux's indices. And how we store the data within those. So if it's all right, Jeremy, I'll pop on my Emacs, if that's all right. That's it. Nope. Try again. Eventually, with all of this working from home, I'm sure we'll all figure out how to do all of these.
Yeah, we just need a big button on our desk to like those ones you have in meeting rooms.
Yes, yeah. How does that look?
Yep, that's good.
All right. So when Crux gets a query in, and I've picked one with sort of fairly standard example here of a teacher teaching a whole load of classes and then students taking those classes. You've probably all seen the type. And Crux has a number of indices with which it uses to evaluate this query. So first of all, and this is how Crux works currently. We've got what we call the AVEC index, or the Attribute Value Entity Content Hash. So in this case, a row in this index would look like, so teacher here would be the attribute, sorry, beg your pardon. Teachers here would be the attribute, science is the value, and let's say John teaches science. We also, because Crux is bitemporal, we keep track of when that fact was true, and that's in terms of the content hash of the document. So first of all, this is the index that we'd look at first for this query. So because we'd see teacher teaches science, and we say, right, I want to narrow down based on that clause first, because I've already got science in hand. Like I know that I'm looking for science teachers. So I can very quickly scan into this index to see who teaches science, and John then becomes a candidate for that part of the query. So we then look into the Bio-Temporal Index, which is an index that's sorted first by the entity ID, so in this case John. It's then sorted by the times at which that was valid, so in this case April the 1st, a transaction ID, and we say this is the content hash of the document John at that time. And so that will tell us whether this entry in the AV index is a valid one. So hopefully we find that's correct. We then look back for the second clause. We then need something that works the other way around. So what's the name of this teacher, right? So we've got sorry, beg your pardon, I've got this the wrong way around. There we go. We've got name as the attribute now that we look up. We've got John in hand. we know the content hash of John at that time, and we find that John's name at that point in time was the string John. And so those are the three main indices that we use within Crux, within Crux's query engine. We've got a few others within there, so those aren't the only indices, but these ones I would say probably account for about half of Crux's disk space, if memory serves. I've not got the exact values to hand, and obviously it depends entirely on your use case. What we've been trying to do though is cut these down fairly significantly, and also by using the object store. So another part of Crux is the object store, which is a mapping from the content hash to the document that we've put in. And obviously that contains all of the documents within Crux as well, in addition to AVEC containing all of the documents within Crux and AECV containing all of the documents. We noticed within these indices that there's quite a lot of duplication, particularly if you've got use cases that don't update like a lot of a document every time. So if you're only making small changes to these documents, you can imagine that we get one entry in these AVEC index with slight changes between each content hash. And so what we'd like to do is cut that down fairly significantly. And what we're looking to cut it down, I mean, it's not quite ready yet, and we're still really measuring the output of this. But what we'd like to cut it down to is an AVE index here, so getting rid of that content hash off the end, and also an AE index here, which would get rid of both the content hash and the value, and making up the shortfall really with the object store, that mapping from content hash to document. And what we're hoping that'll do is that it, let's say, removes an awful lot of the duplication within those indices at a slight cost to the performance of queries. So it's about that balance really between query speed and disk space usage. So hopefully we can find a good balance there, but an awful lot more profiling still to be done. On that subject of profiling, actually, the other potential disk space saving that I think Jeremy presented on that slide was using an attribute dictionary instead of using the full attribute every time. So within these indices in Crux, we actually take a hash of each of these. And the reason, actually, there's a couple of reasons we take a hash. First of all, is that it means that all of the parts of the index are the same size, because we hash it all with SHA-1. At least for now, and so we know that each of the parts of these indices is 20 bytes, and that makes quite a lot of the processing quite a lot easier. But the other reason we hash this is also for sensitivity reasons. So what it does is it cuts down the amount of potentially sort of sensitive data that's stored within these indices. And so the only place that we store sensitive data, or in Crux, in the Crux nodes, is then within the object store itself. And so we know that if we later get a request to remove that data in line with sort of GDPR, say for example, we know that we've not got we don't store that data all over the place. It's stored in very specific places. That said, I mean, 20 bytes is quite wide, especially when you're looking at an awful lot of these entries. So the attribute dictionary is an idea we've been playing with, which actually cuts down the size of the attribute part of these rows from 20 bytes, hopefully down to 4, on the assumption that there aren't many use cases that have more than, I think it's 4 billion attributes. I think that gets us with 4 byte int there. The measurement side of that, and this is something we all relearn, I think, on a regular basis. So we all thought, yeah, 20 bytes down to 4, that brings what 60 bytes down to 44. That's got to be a performance saving. But funny thing happened there. When we measured that, it actually didn't reduce the overall disk size by an awful lot. In fact, it increased it. And we're still looking into the reasons why that might be. Obviously, one of the reasons is sort of coding fails on our part, but it could also interfere with the sorts of compression algorithms that RocksDB, for example, uses in the underlying indices. So yeah, measurement's absolutely crucial here. And with that in mind, actually, I think the next, if I can come back onto the next item of Jeremy's agenda.
Yeah. So I can present
maybe that's a good point to start for questions as well.
Yeah, let's open it for questions. Yeah. So I thought it was a great example. And obviously there's nothing, you haven't mentioned the temporal indexes too much, but all the stuff you're describing, like we're leaving those ones completely alone, right?
Yes.
Because there's a separation between the attributes and values and which content hash is valid at which time.
Yes, we're leaving those well alone for the time being.
Okay. All right. Well, unless anyone else has a question to interject with, the next bit would be the performance benchmark numbers. So I have a couple of numbers to show up on the screen very briefly, and then I'll give it back.
Yeah, go for it.
Give it back to you, James. So what do we have? So from last night's bench run, so this is our now fully repeatable automated bench environment, throwing out ingestion numbers. We can talk about how those metrics are gathered in a second, but we're looking at 300 megabytes a minute, or 5 megabytes a second for ingestion, basically. And obviously that can be cut many ways depending whether you're talking about like a few large documents or many small documents, or maybe actually your transactions contain like compare and swap. So yeah, exactly how ingestion applies to your use case will vary, but we at least now have some numbers we're able to start sharing publicly. So the intention is that we'll make these dashboards and some of the outputs from these reports available on the GitHub soon. So anyway, this is something we're very conscious of. It's like one of the main drivers behind Crux was having fast ingestion. So that's good to have some numbers to show. So James, you want to explain how we got those numbers in? Oh, you're on mute.
Yeah, you're muted.
I'm muted. That old remote call chestnut. Right. So I can actually add to that with the metrics that we. Oh, where's that gone? There we go. So this is actually making good use of a lot of the work that we've been doing over recent months. And I think Tom's on the call as well. So Tom gets. I think this might even be the first chance Tom's seen of how we've been putting this into practice.
Yeah.
So we've been spending quite a lot of time, investing quite a lot of time in our benchmarking infrastructure, and actually we've made quite a lot of this available as a Crux module, Crux metrics, for you to use in your own operations monitoring as well. But this is an example of our overnight bench run yesterday evening, and we can see how the bench runs behaved. We've actually got a number of distinct benchmarks, as you can probably see here.
Oh no, sorry. It's showing me your face for some reason rather than your screen.
Yeah, can you click on stop presenting again, James? Yeah, there you go.
Yeah, cool.
How's that?
Yeah, there we go. Lovely.
Excellent. Yeah, so this is using the CloudWatch plugin for Crux metrics, and you can see here we've got a number of different benchmarks that we're running here, various ingests and various sets of queries. So this is where our benchmarking numbers are coming from. But yeah, you see the red line coming through here is the amount of bytes that we're indexing into Crux, and that's up against the left-hand y-axis. And then the other side, we've got what we call indexed AVs. So Crux, a lot of the ingesting algorithms of Crux depend on the amount of AVs or attributes and values within your documents. It's proportional to the amount of AVs you've got within your documents. So we're explicitly measuring that and looking to optimize that over time as well. The amount of indexed docs, I mean, docs obviously in this case depends very much on how big your docs are. So we're less important as a metric, but still quite interesting nonetheless. But with bench though, I mean, these are all very sort of specific and I would say sort of tailored to looking at performance optimizations. But one of the areas we've also been particularly interested in recently is looking at how real live production deployments of Crux might look, and making sure that the performance optimizations we get here do actually apply to real world use cases as well. So I'll hand over to Dan to talk about the soak data cluster.
Thank you, James. This is the next point on the agenda, so I'll move on. You can continue presenting, Jeremy, because I'm not going to present anything for this. But I'm going to start by continuing what James said in that. So Crux soak is intended as a Crux production deployment. It fetches data from a data source on a regular basis and displays it on a web service. And just a little note on what that web service does and kind of how it makes use of Crux. It's currently a weather service, so it gathers weather readings and forecasts from open weather map from a set of different locations. And on the web service itself, what it actually does is it collects these forecasts kind of over time. So you can see say you go to a location and look at the time now, you can see the past 5 days worth of forecasts and see kind of how does the forecast change over time. And then also alongside that, there's a date picker, so you can go to anytime you want. You can go a few days in the future or days in the past, and you can see over time how the weather's changed, how the forecast has changed, and so on and so forth. So if you want to look at that and you want to play with that, that's at soak.crux.cloud, which I imagine we'll drop a link to on the YouTube upload of this, and I'll also drop one in the Hangouts chat. Yes, only 5 days of forecast. Yeah, I thought I did mention that, but yeah. Also, we only have forecasts for the next 5 days. So if you go forwards 5 days, then yeah, there'll be no data past that point. But regardless, so it's been fairly helpful to us, and it kind of has a couple of purposes to it. Firstly, it's kind of it's an example for other people to follow. It's got it's running Crux on AWS and using also Confluent Cloud. And I should mention that the thing that we mentioned earlier with the polling issue, we actually found that because of this. So that kind of leads on to the other purpose of it. So first purpose is, as an example, we have CloudFormation templates. And people can recreate it, they can set it up, they can maybe follow a similar architecture. But also for us, it's useful, as James said, as a running Crux cluster. So we can see how it performs at volume, and also see what issues we run into, help fix those. So there's kind of, I'd say, the main things we kind of want to get out of it in terms of insights from it is, how does it perform? How do the metrics perform? What can we tell from there? And also the maintenance in running a cluster, like updating it and updating your indexes and things like that, which is a thing that people are going to run into. So how can we do that? How does it feel for us to run it? So I'm not going to go too deep into the details. It's the whole thing is available on the repository. So I'll also send a link to that in the meet, and I would also put that on the YouTube description. But yeah, it's there for people to have a look through. There's the example code, there's the CloudFormation templates. And probably as a kind of closing note on it, I'd say there's more to be done. There's more that we want to do, especially on the maintenance side of things. Like, next thing we want to look at is backing up the contents of nodes on AWS, how we're going to go about doing that. And then also, we want to add more examples as we go on. So one thing that we were thinking about next, potentially, is solar measurements. So I think that's fairly exciting. Just to see kind of different use cases of bitemporality, and just kind of like nice little examples for people to look at. And just more data coming in so we can also see better how it performs. And that's basically it. I recommend taking a look at the links. Personally, I think it would be an interesting thing to look at. And that's me done.
Thanks, Dan. That's very good. So again, chance for questions or advice or whatever. I was just checking the temperature in Southampton. It is approximately correct. Okay, so the next thing to discuss was sort of the API work, and James has been working on this a little bit. So again, James, if you want to take the floor for a moment, I'm just showing up the Java.
Yep, absolutely. So this is part of a longer block of work, really, for us, in that as we move towards beta and general availability. One of the things we'd really like to do is make sure that the APIs are completely consistent, and also to a degree idiomatic on the various platforms that we target. So we target both Java and Clojure users, and obviously the idioms for those are quite different. So we're looking at what's best for each of those environments, but hopefully without a completely different API for both. So one of the things we've been looking for particularly is around the lazy queries. Now, lazy queries, particularly in functional programming, form quite an interesting design pattern, particularly when you've got the overlap of laziness and resources that need to be closed. So we like laziness for a lot of reasons. It means that we can keep a lot more in memory. Do a lot more with a lot less memory than we would otherwise need for massive data sets, for example. So laziness is good, but also closing resources is good as well. And the combination of those often tends to lead to some quite counterintuitive errors. So, for example, if you don't end up using the entirety of your lazy query before the resource gets closed, I think we've all probably run into at some point those kind of resource closed type errors, those illegal state exceptions. In Java, I mean, what we'd like to look like, and actually, if anyone's got any feedback on any of these kind of APIs, that'd be great as well. Obviously, I think we can get in touch through all the usual channels for this one. But for the Java API, we're quite keen on using the Streams API that was introduced, I think, in Java 8, so quite a long time ago now. But this maps quite nicely into lazy queries. Streams themselves are closable, and they actually offer quite a surprisingly functional for Java API here. So we're looking into that for the Java side. On the closure side, Jeremy, have you got one for the looks like enclosure?
Actually, I didn't have it up.
Right.
Sorry, I don't know if you have it handy. I can tab across to the repository. It's on your branch, isn't it? It's the PR.
Sorry, I'm out of there. We'll do it live.
Okay. I think
because that's never gone wrong for anyone ever. So I've actually got the different branch checks out at the moment, so I'm not going to run any live examples, but we're looking to make good use of closures with open here. So a result set that comes from Crux's OpenQ function. OpenQ takes a database, if memory serves, so that deals with all of your time parameters, and we'll say find. Tell you what, let's use this example from up top. That won't be far off what we're looking for. We're then saying that because this is in a with open block, we're mandating that you use res in its entirety in here. So a way to do that might be, for example, to print out all of the rows in the result set to screen. So if I print row, for example. So here, because I'm using doseek, I'm making sure that I've exhausted res here. Chances are the sorts of errors you've seen with laziness and resources are things if you do like take to res, and because take is lazy, it escapes the with open block, and any resources that result set needed have been given back to the system, and that's when you get the laziness errors. But yeah, make sure you fully realize these sequences. Sorry, fully use these sequences within the with open block. But yeah, I think the main thing here is that we're trying to make res look as close to a normal closure sequence as possible, but also being suitable for use within a with open block.
So I'll just take control of the screen back. I actually think the PR is quite a nice way of looking at it. You can see
go for
the left to right conversion. We're actually reducing our test sizes by having a simplified API. No mention of snapshots. We also had the feedback from people that aren't familiar with like using RocksDB snapshots. So just the concept of a snapshot is a bit unfamiliar, and there's a conflation between a snapshot and a DB. Because a DB is supposed to be the value, but actually really snapshots like the actual concrete resource value. So that these are the sort of things we're looking at. So OpenQ is the first step to rationalizing how that works. So I guess no promises about how we change other things yet. But, this is a good start.
And TX log at the bottom as well. I just noticed that one in there. So there's TX log, but we're also looking at the various history APIs as well, particularly as history is probably quite amenable to streaming through the results as well.
Yeah, and of course the reason why you'd want to do all the streaming is so you can mix your data log or just these streams with your closure code, so you're not having to figure out how to do everything in Datalog. So we have an example in the repo around this IMDb test, which does a bidirectional breadth first search, and it's mixing up multiple queries against the same snapshot. So there's a lot of interoperation happening there. So it would be great to be able to showcase that in a simpler way that doesn't use such fiddly resource handling. Cool.
Just to round this one off briefly, so I mentioned a little bit earlier about the beta and general availability. I think part of the make sure that by the time we do get to fully through the beta and through people can really depend on. And at that point, we'd like to lock the API down to a degree.
Yeah, I think there might be some audio issue there. I don't know if everyone else heard that, but yeah, I think I caught that. But yes, there's probably worth having a quick update on what the state of the beta is actually. So one of the things we're hoping to aim for is a beta release in the next month or two, and then general availability by the summer. And that's still roughly the plan, although we're taking our time over it because we don't have that sort of immediate pressure to do it. So we just want to make sure we get it right. But if you have a particular question around that, let me know. We can talk. But certainly, there are people using it in production. In fact, we just heard one of the users, so Visi, so that they've been quite public talking about their use of Crux. So they've just gone live successfully with another service based on Crux. So yeah, lots of people are using it. So yeah, lots of also people like migrating between versions of Crux already. So that process, one of the advantages of the Crux architecture is that you can rebuild the indexes. It doesn't matter if we change how the index model works, because as long as you can rebuild from the source data, you're never going to get stuck. So that's also proving itself out in the world. Okay, so I think the next thing to look at is this Q&A. I think we're done with the main content, and happy to wrap up the call near enough in the next few minutes. But if anyone, Jerome or Alex or anyone else wants to ask a question, please go ahead. All right. Okay, I'm going to stop recording and have a good weekend.